Hey guys, welcome. This is 10.6 video. We're starting circles, and what better way to start circles than doing a lot of vocabulary. So what I'd like you guys to do is go ahead and work through this vocab, and so best thing would do to write it down and also include this picture to start it out. So a circle is a set of all points equidistant from the center, which in this picture would be P. So every single point on this circle, same distance from P, we call that the radius. A diameter is a segment that contains the center and it hits the endpoints, and a radius would be half of that. And congruent circles have congruent radii, and a central angle is an angle whose vertex is the center of the angle. So BPC would be a central angle right here. APC is a central angle. So it's a perfect picture. So go ahead and write that down, and while we're at it, we're going to also write this part down right here with this picture. So this picture included, write all that. Arc is a part of a circle, so we're going to also be talking about arcs, which is not the full circumference of the circle, but a portion of the circle. One type of arc we would call a semicircle, and a minor arc is smaller than a semicircle. So if a semicircle is 180 degrees, an arc is going to be, a minor arc is going to be less than 180, and a major arc is larger than a semicircle, so it's going to be bigger than 180. You name a minor arc by its endpoints, and we use and name a major arc or a semicircle by its endpoints and another point on the arc. So major arcs have 3 points that we use. Minor arcs we only use 2. Okay, so make sure you guys get that down, and let's go ahead and get some more vocab down while we're at it. So this is kind of a heavier vocab chapter. Okay, let's take a look at our first little note. So please write down this box, and it's arc measure. So how can we find an arc's measure? Well, the measure of a minor's arc is equal to the measure of its corresponding central angle. So if we know the central angle, it's going to be congruent to the arc. And the measure of a major arc is related to the minor arcs are actually by 360. So we have RT if 50 degrees is in here, then we know the minor arc. And to find the major arc, this bigger one, which we call TQR, that would be taking 360 degrees, that's the total degrees of a circle, and we subtract the 50 degrees and we're left with 310. So that's arc measure. We'll take a look at an example of those. Arc addition postulate, you can add arcs together just like angle addition postulate, segment addition postulates. This is just another simple, if I add A to B and I add B to C, then I'm going to get major arc ABC. Okay, so write that one down. Hopefully we know this one. You can write this one down. You don't have to draw the picture, but our circumference of a circle we will be using quite a bit is the circumference equals pi d, or 2 pi r. Again, 2 times the radius is the diameter, so it's pretty much the same thing. And our last one, arc length. So there's arc measure, which is using degrees, and arc length, which is a distance. So that's going to be a number. So to find arc length, you basically are finding the ratio of the full circle. So what part of the circle, which we would use the length of the arc's measure. So we take the measure of the arc, divide it by 360. That'll give us the ratio of how much the circle we're looking at, and then we multiply it by the total circumference. So it'd be like if the circumference around a circle is 14 pi, and we said what's a semicircle's arc length? Well, it would be half of that, because 180 divided by 360 is 1/2, and we get 7 pi. Okay. Hopefully this will make a little bit more sense as we jump into a couple problems. And our first problem is being able to name some arcs. So let's go ahead and look at some options. So if you write down this whole problem, I would appreciate it. What are the minor arcs? Again, a minor arc is less than 180. So let's go ahead and see if we can figure out which one is correct. PQ, so from P to Q, that would be less than 180, so that works. I'm just going to check mark it. PS. Now that is PS right here is going to be less than 180. PR looks like it might not be. QR, I think that one's good. And RS, I think that one is good as well. So that one looks pretty good. Let's see the ones that we match up. So we had RS here, RS here, RS here. That's good. QR, QR, and QR, and PS, and PS, and PS, and PQ, and PQ, and PQ. So this one shares pretty much with all of them. Is QS1? QS would be 1. Okay, QS, or it potentially could not be 1 if we go the other way. So that one's an iffy one. And PQR. PQR is going to be a semicircle, so that doesn't work. And PQR, again, that one does not work. So this is kind of the big one in question. So let's take a look at our correct answer. And it is this one. QS would also be a minor arc. If we said QRS, then it would not be. Okay? So we get right there our answer. Alright, let's take a look at another problem. So now we're going to look at finding the measure of an arc. Okay, so what is the measure of BC? So since we have the central angle, the measure of BC is just going to be straight from it. My wife's chilling on the couch, you know, no big deal. Do you want her to give a shout out? Just say something if you want her to. I can't hear you. Okay, oh well. So to find the measure of BC, we're just going to move on. We take the central angle BOC and we just translate it straight to our arc. So the arc measure of BC is 32. Okay, second part. So you're going to write all these little parts down. BD. So BD, again, according to arc addition postulate, we can add arcs together. So we should be able to add 32 and 58 together to find BD. And that's what they're trying to make you think about. You don't have to write that. I already said it. Arc addition postulate. We got this. Okay. So we add BC and CD, and we get 90 degrees. Okay. So it's 90 degrees. Boom. I'm going to move my face over here. ABC is going to be, if you look at it, AC is a diameter, so ABC should just be 180. Semicircles are 180, so that's it. And last part is D, AB. To find AB, we have 32, and if we take 32 away from 180, we should be able to get it. Sorry about that. So if we have that whole segment, we can subtract to find it. And that's what we did, subtract on both sides. And we should get 180 minus 32, and we get 148. Okay? So there you go. Finding arc measures is using that kind of 180 for a semicircle, using central angles to find our arc measure. Again, that's not arc length, it's arc measure. And there's 360 degrees total. Alright, let's move along. We are getting there. We have 2 more. So we're not doing this problem, we're going to be doing this problem. Alright, so write this problem down if you can, draw that picture. This is a car has a circular turning radius of 16.1 feet. The distance between the front tire is 4.7. How much further does a tire on the outside of it turn than on the inside? So first of all, let's find 2 circumferences. We're going to find we'll say the outside tire, out tire, and we'll go in tire. Okay, so we got the outside and the inside tire. So to find the circumference, we're going to do C equals 2 pi r. So the outside tire is 16.1 for the radius. And we're just going to multiply that 2. We'll keep everything in terms of pi. And 16.1 times 2 is going to give us 32.2 pi. So we'll leave that there. The inside, now the inside is 4.7 shorter, so to find the radius of the inside, we're going to take 16.1 and subtract 4.7. And we should come up with about 11.4. And we're going to use that guy. So we get C equals 2 pi r. And we're going to get 11.4 for the radius. and multiply that number by 2. And we should get 22.8 pi. Okay, so that's the difference of the two different ones. How much further does the tire go? So if we go ahead and just subtract these, we should get the difference, or the different amount. So 32.2 minus 22.8, and we come up with about 9.4 pi feet would be our difference between the two of them. Okay, so we're using circumference to help us set up and solve this problem. Okay, and so right there, that's a good reason why our tires spin differently at different rates. So usually your car has power going to one tire, not both. If you had power going to both tires at the same time and you were doing a circle like that, you might have some problems in your differential. So that would not be good. Let's look at our last problem. Arc length. Okay, last piece. What is the length of the arc shown in red? Leave your answers in terms of pi. Alright, well first of all, arc length, okay, arc length, AL, is, it's the measure over 360, so the measure of the arc over 360 multiplied by our circumference, 2 pi r. So this is the measure of the arc, just like that. Okay, so our central angle here is 90 degrees, so the arc measure is 90 degrees. And so what we're going to do is we're going to do 90 divided by 360, and hopefully you can do that in your head. That's 1/4 times 2 pi r. Well, we have 16 as our diameter. Our radius must be 8, but then you multiply it by 2. Pi d would have worked. So we get 16 pi, which is pretty convenient. And then we take 1/4 of that, and you get 4 pi. And so what's the length? It's 4 pi. So a lot in this chapter, but realistically, not too much. Okay? So good day, y'all, and I'll see you when I see you. Do you think we can get my wife to make an appearance? I'll see what I can do. Jess? Jess? I don't think it's gonna happen. Sorry, guys.